Oh, that is just beautiful. I could not be happier with that. That is gorgeous. Well, I could be if these screws were silver instead of black. Welcome back to Cloud 42. I'm James. As you know, I am in the middle of developing an electronic lead screw for my lathe, which is a device that replaces the change gears with an electronic controller and a motor. Last time, we assembled and tested a PC board for the interface electronics, and this time we're going to machine a proper enclosure for the control panel with actual labels on the buttons, so I don't have to guess. This is the box we're going to use for the control panel. This is a die-cast aluminum box made by Bud Industries. Now they make these in all shapes and sizes, and they also make them in plastic. And these are similar to the ubiquitous plastic project enclosures that Radio Shack sold for years and years. So it's just a die-cast aluminum box. The lid's about 80 thou thick, with 4 screws to close it up. Now, we are going to take this a little further than the typical hand drill and label maker hobby treatment, and we're going to machine out the front for the buttons and the display, and we're going to try a couple of different techniques for labeling the buttons. You've seen in previous videos I have a diamond drag engraver, and we will try that, just diamond drag engraving the surface because that's fast. But I also want to try V-bit engraving the labels so that they're sunk in a little bit and I can fill them with paint. And we'll give that a try. So let's take a couple of these boxes over to the mill and see how it works. Now we're eventually going to need some mounting holes or some mounting slots in the back of this box. And so I'm going to go ahead and cut those first, just so that when we have it flipped over face up and we're doing all the machining on the faceplate, there will be some holes in the bottom that the coolant can drain out through, so we don't end up just filling the thing completely full of coolant. I'm going to use an 1/8 inch aluminum specific bit, and I'm going to cut a slot, a vertical one and a horizontal one, approximately the correct spacing to match the screws that are already on the front faceplate of the lathe. That way we can just mount it and have a little bit of play to get it level, and just in case the screw spacing isn't exactly right or the screws are not drilled exactly level, which has been the case on most of these import machines, we'll have a little bit of adjustability. So let me grab an 1/8 inch end mill and let's put some slots in here. Okay, that looks perfect. Let me grab the other box and let's go ahead and cut the other one while we have the setup. Very nice. Also, before we do the faceplate, I need to put a connector hole in the end of the box for the GX16 connector to attach this to the controller. And so I'm just going to go ahead and mill that out as well. I think this is going to be plenty rigid to just hold it vertically like this. The position of this is not super critical. And while I'm at it, I'm going to go ahead and use a stop just so that I can do a second one without having to get the second one in exactly the same position. Okay, that looks pretty good. Let's do a sanity check with an actual connector. Oh yeah, look at that. Cannot beat that. Could it be a little tighter? It could be a little tighter, but it's not going to hurt anything. Very happy with that. Okay, let me switch things around and we'll get set up to do the face. Okay, so for doing the faceplate, the face of this, I'm going to be doing several setups, right? Because I've got 2 boxes, and I need to cut the holes out of each, and then I need to do the diamond drag engraving on one of the boxes, and the V-bit engraving on the other. So I'm going to be taking these things in and out several times to get all of that done. So I've got a couple of parallels here in the bottom just to space this up so it's close to the top of the jaws, and I have an end stop right here so that I can keep placing it in the same position over and over again. This is exactly what I'd be doing if I was doing a production run of these. Today I'm just doing 2. I'm going to try to make sure I'm holding this tight enough to hold it, keep it from moving, but not so tight that I bow the top or distort it, or break it, which should certainly be possible. Okay, let me grab an edge finder. I can't get on the outside edges, but these jaws should be the same thickness so I can hit from the front and the back. And even if they're slightly off, it's not going to be by enough to matter. Okay, and there's my Z. I am extremely happy with that. That is just beautiful. Now, the last operation here is these 4 screw holes that are going to hold the PC board in need to be countersunk, and I'm using flathead socket cap screws, and I'd like those to sit down flush. So let me grab a 90-degree drill, and we'll try to countersink those. Now, I have intentionally set up the CNC code to run them shallow because I don't want to over drill in this, and because of the width of the tip of the drill is hard to judge and hard to measure. I'm not sure exactly where this will hit, so I set it up so it should be 25 thou too shallow. It probably won't be that much, and then we'll walk it in. Now this part's a little bit scary because it's a great big drill and I've only got 2 of these boxes today, so. try a screw in one of these holes. Okay, yeah, still proud of the top, which is good. That's what I was hoping for. Let's see just how proud it is. Looks like 20 thou. So I need to drop that another 20. Let me check some of these other ones. $20. It says 19, so I'll go ahead and sink it 20 and we'll call it good. Okay, that one is still about, I chickened out and I didn't run it completely flush. I left them slightly proud. See, that one's almost flush. It sticks up just maybe 2 or 3 thou. That one's about the same. That one's about the same. That feels maybe 5 thou proud. So I think that's going to be fine. I have a hand countersink. I can just come back and rip around those and sink them in further if I want to get them adjusted perfectly, but I don't know how precisely these boxes are cast, and so I don't want to shoot through the next one and have it be too deep. So let me grab the other box and let's run it. Okay, we have the faceplates milled out, and actually those look really nice. I'm very happy with how that turned out. I was a little bit leery about doing the countersinks with the CNC, but you know, once you walk it in, it's pretty good. So I'm very happy with that. Next, we need to do some engraving. I'm going to do one of these with a diamond drag engraver, and I'm going to do one of them with a V-bit. Now, the diamond drag engraver has a spring, so the height, the Z height, is not super important. But for the V-bit engraving, since we're milling to a particular depth, and it's only like, 15 thou deep, the Z height needs to be really consistent. And one of the things that I've noticed is that these boxes are not entirely flat. This one's a lot flatter than that one, so I'll save the flat one and we'll use it for the V-bit engraving, and we'll take the one that's a little bit less flat and we'll start out with the diamond drag engraver. Just because it's so much more forgiving. Okay, let me grab the diamond drag engraver tool and let's engrave it. Now the diamond drag engraver does just what its name implies. It just drags a diamond on the surface, so it's not going to be spinning. I will put a little bit of coolant on it, not to keep it cool, but just to add just the tiniest little bit of lubricant to the surface, just to keep the aluminum from galling up on the tool. I don't know that that's really an issue, but it won't hurt anything to lubricate it a little bit. Let's load the right G code before we do this, though. I don't know how well you can see that on camera, but the diamond drag engraving is there. It's very clean. It's just very small and, you know, doesn't really stand out that much against the aluminum. It's not really much of a burr. I'll have to see if I can put some paint in that or if it's just too small. Let's take this other box and see how level we can get it mounted so we can do the V-bit engraving. I'm going to start by just sort of snugging that in here. Now I'm going to grab an indicator because I'd like to see just how level the top of this is. I don't really know. It's not super critical, but if I can get it within about 5 thou or less, I think we'll be fine. So that's about 0. That's about 1. And over here we're slightly minus. Let's see what happens if I tap down this side. Not much, okay? Let me do something super unorthodox and pry up this side. So that's about -2 there on both sides. If I go up here to the top, we're at about -2. And we're right about 0. I can live with that. That's within about 2 thou all the way across. If I were going to be doing a lot of these, I would probably want to make a fixture that this plate sat on and got clamped to or screwed to that actually supported it directly under the top so it was all right about the same height, and it could be done repeatedly since apparently the boxes are not perfectly consistent. But since I'm going to only do one, I'll set it up by hand and make it work. This is going to take a while. Oh, that looks pretty good. I'm pretty happy with that. I don't want to round anything over, but I just want to very lightly take the burrs off. Now this is going to be, I do not want to put a real bright shiny chamfer, so I'm just going to very lightly kind of scrape around it. I just want the burr gone. Same down here. That's the worst part right there. Just don't want the tool to catch and leave a big shiny spot. And I think that will do. Okay, let's take it over to the bench and see how we did. So I've got both of these faceplates here. This is the one that was diamond drag engraved. And you know, the markings are there, they're definitely clear. I have done, since this came off the mill, the only thing that I've done to it is I've taken some gray Scotch-Brite and just buffed the face of it. And that just takes off whatever burrs there are in the engravings. And of course, after I did that, then the engravings were full of you know, black grit from the Scotch-Brite and from the aluminum. And they stood out really well. But then I went and took it in and cleaned it because that's no good. It just looks like it was all grimy from being in the shop. And you know, it'll pick up that look eventually and it'll be really easy to read. But for now, I want to try something different. So that's the diamond drag engrave. This is the V-bit engraved one. And you can see the markings are a little clearer and a little easier to see. They are small, and of course these really filled up with junk when I took the Scotch-Brite to it. But I want to try embedding paint in it. So I've got some paints. These are just testers enamel. I've got some black and I've got some red. And we're going to try dropping some paint into these engravings. We'll try the biggest ones here first and see how those go, and then decide what to do about the rest. Worst case, I think I can get a toothbrush and some acetone, take it all out if we have to, or just make another one. These boxes are only a couple of bucks. So let me grab a little applicator and let's see if I can put some paint in here. I'm going to use a jeweler's visor so I can see what's happening. I think I could probably just put the paint in here and then let it dry completely and take off the stuff from the surface with the Scotch-Brite. But of course that's going to leave all kinds of grit down in there, and I'd kind of like to avoid that. It's going to get filled up soon enough, I guess. So I'm not really filling these with paint as much as I am just trying to paint the inside of the engraving. Okay, now let me take a paper towel and try wiping that off. Oh, that looks really nice. You see that? That looks nice. I really like that. I'm going to see if I can put just a little bit more in there. See if I can make it a little darker by getting it wetter. And we'll do the same drill, wipe it off. That looks really nice. Okay, I'm going to do the same thing on all of these now. Just going to flood them with paint and then wipe them off. Very nice. Okay, this is working way better than I had even hoped. Let's do the small ones across the top. Try not to get it down in the holes here. Wow, that looks beautiful. Okay, let's try something down here on my logo. That red's really smearing. I don't want to come back with Scotch-Brite on this because I think that's going to completely destroy the red by filling it with just black grit. I'm pretty happy with that. It's pretty easy to read. I don't know how well you can see it, but I sure can. Okay, I'm going to let this dry a little bit, and now Then maybe hit the top of this with some acetone very lightly just to try to make sure we've got the extra red smearing off. And I think this one's good to go. Actually, why don't I try, see what happens with the diamond drag engraving. See if I can put a little color in that as well. I have no idea how this will work. We'll try it just here on the RPM first. And that's going to be a resounding no. The paint all just wiped directly out. Okay, let me let that dry a little bit and we'll come back and put this thing together. Well, that was just a light wipe with acetone, and that is beautiful and clean. I'm very, very happy with those results. Cannot complain about that at all. Okay, let's move on to the next step of assembly. So this is the PC board that ultimately needs to go behind this panel. And when I made the 3D printed version of it, it was really easy because I could just 3D print standoffs on the back. Of course, this isn't 3D printed, it's machined, so I need a spacer. So I 3D printed a plastic spacer that will fit over this and fit behind the panel. Now, I could have just used some little standoffs or even 3D printed some plastic standoffs, but I wanted to do this whole frame for a reason. And that is, when you've seen this running before, you know that it can be difficult to read the display. And the solution for that is to use red filter film. It says this is a red display, you put a red filter over it, and then these kind of white digits that are showing get muted, and so the red stands out a lot more. Now, I don't have any of that, but a viewer, thank you very much, Mark, sent me some pieces of film that he had left over from a project. And he sent a piece of red, and a piece of green, and a piece of blue, because there are different colored displays. Now, the one that I have is red, so the purpose in 3D printing this spacer with the full frame around it is to give me a place to stick down the red filter film. So, let's cut a piece of this film about the right size and put it on. When I say about the right size, I'm going to be a little generous with it and then trim it afterward. Yeah, you can see how it dims those down. You can barely even see them, and when they're on, they'll glow nice and bright. Okay, let me get a knife here, trim this up. And there we have it. Well, that will fit over this, and the whole thing will go inside here. Oh, that's nice. That's pretty. As with the prototypes I showed before, I've got some 3D printed buttons. These are flexible material made from Ninja Flex. Put those in like that. Flip this over. And I'm going to grab some screws. Now, I'm a little bit disappointed. I could not find any silver or zinc or stainless steel screws. The only screws the right length in a socket flathead that I had are black oxide, so these are not going to look real great, but I will get some later today that are correct and swap them out. And I also, because this is going to be mounted on a machine that's going to be moving and vibrating, I will replace these simple hex nuts with nylon insert lock nuts as well, which I also don't have any of, so I need to go to the hardware store. Wow, look at that. Okay, I'm really happy with that. Of course, with these screws not black, with those silver, it'll be even better. Let's grab a cable and some electronics and at least just power this thing up and see what it looks like. And let's power it up. Oh, that is beautiful. Look at that. That is really easy to read. Plus, minus, here's the inch, millimeter, millimeter, inch. Feed thread, that's TPI, millimeter. Oh, the lights actually show through really nice. Forward and reverse. See the forward and reverse light switching. No settings right now. So let's say we want to go back to feed in inches. There we go. We want to do threading. We switch over to thread and we can go to inches or millimeters. Oh, that is just beautiful. I could not be happier with that. It's gorgeous. Well, I could be if these screws were silver instead of black. And we'll take care of that shortly. It is later in the day and the paint is dry. You can also tell because I'm wearing a different shirt. I had a chance to go to the hardware store and get some different screws, and these are stainless, and I think they just really make this pop. I was a little unhappy with the black. I'm very happy with the stainless, kind of blends in with the aluminum. Zinc would be better just to make sure that we don't get any cold welding between the stainless steel and the aluminum, but the only place it's making contact is just on this countersink, so it's not a big deal. It might be an issue if I were threading it into the aluminum, but I'm not. So you can see how that came out. I'm really happy with the markings. They're very clear, very easy to read. The colors all come together well. And then on the back, I've got nylon locking nuts on the back of these, and those are just screwed down just tight enough to hold it firmly in place. And I've got the connector here ready to go, and then we just need to put a box here on the lathe. Now I've got the box ready to go, and it's got these 2 holes in it, 2 slots that we milled on the back of it. And the reason I did one vertical and one horizontal is because I want to put it on these 2 screws on the front of the lathe. I measured the distance between them, but I wanted a horizontal slot to give myself some leeway in case it wasn't exactly right. And then I wanted a vertical slot to give me some leeway in case they weren't exactly level. So these screws on the G0602, these are M4 by 0.7. So I'll just take out these, and these ones are really short, so I got some longer ones. Okay, that hits just about in the center of the slot. I'll go ahead and tighten that down and then adjust it vertically till it looks to me like it's about level. And snug those down. Looks pretty good. And that is really solid connected to the lathe. I'm happy with that. Then I've got the panel, and paying attention to which way I put the connector on. So this is a little wiring harness. I just took 5 pins from this GX16 8-pin connector and ran them through to the 5 pins on the header on the back here with a little loop of wire and some heat shrink, so it'll be nice and secure. And that will just loop back in the container without being pinched. And put in the screws. Now I thought about getting some socket head flat screws for these corners. These are 632, and there's 2 reasons I didn't do it. One is then I would have metric and imperial socket head cap screws on the front of this thing. And I figured it was easier to have metric and Phillips. The other reason I didn't do it is because at my local hardware store it was like 50 to 60 cents per screw for these little things, and I didn't feel like spending $12 just to pick up some screws because I hadn't planned ahead, so we'll just stick with the ones that came in the box. Well, I could not be happier with the way this has turned out. It's really nice and clean. The engraving is nice and clean with the ink or the paint in it. It's very easy to read. Right here on the front of the lathe, it's just right in my line of sight. So it's, near eye level for me, kind of pointed up a little bit, and so it's going to be really easy to see the display and the indicators. It's high enough that it's above the speed control for the VFD, almost like somebody planned it that way. And as I'm turning the speed control, I'll have the RPM readout right here, so that's really handy. And then I've got all my controls for the electronic lead screw for my feeds and threads. It's just, it's beautiful. It's way better than I even imagined. So I am happy with this. Unfortunately, I don't have the electronics set up for this kind of connector, so I can't just plug it in and power it on. I had it on over on the bench earlier and you got to see that. But we will continue working on the electronics and try to get this thing wrapped up into a form that can be a permanent installation, and we will keep working on that next time. In the meantime, if you are enjoying these videos, please give me a thumbs up. Feel free to subscribe to the channel and leave me a comment. I'd like to know what you think. Thank you for watching.